Distributive property. A variable is an unknown quantity or some quantity that can change, and we've been working with those quite a bit. They generally can mean something very specific like distance or Fahrenheit or length, things like that. The distributive property is used to work with expressions that have variables, because when we use the distributive property we can sort of simplify things a little bit better. And we can also expand expressions using the distributive property, and we can factor a quantity out of an expression by using the distributive property, and that is the reverse process of distributing. And we call it the reverse distribution property or things like that, but it really is the official distribution property. So the distributive property says that if you have A times some quantity, B plus C, that you can distribute the A inside the parentheses and end up with this plus comes over to here, and you can end up with A times B plus A times C. Now notice that you've got to have addition inside your parentheses for it to really be the distributive property. Otherwise you're not really distributing, and it's probably not legal. So the distributive property says a number multiplied by a sum of some numbers can be multiplied by each number in the sum. So a specific example that you can try out would be 3 times 2, so that's going to give me 6, plus, and there's a plus, 3 times 3, which would give me 9. And then when I add those two, I get 15. Now, if I try that, and I don't use the distributive property, but I just follow the order of operations, it should come out the same way. Let's see. So order of operations says take care of what's inside the parentheses first. So 2 plus 3, and there I get 5. And then the 3 out front, that's multiply, so that's 3 times 5, and that also comes to 15. So they're equal. Either the distributive property or order of operations are going to work for you here. So with numbers, we don't usually use distributive property with numbers only, but to understand how it's equivalent, it's helpful to use a numbers only example. So here, using order of operations, this is what I just showed you. So I would do the 3 plus 8 first, and I get 11. And then I'm multiplying by 5, so I have 55. Over here, let's use the distributive property first. So we'll distribute here, and that would be 5 times 3 plus 5 times 8. And then I multiply each of those separately and add the results together. So 5 times 3 gives me 15, and 5 times 8 gives me 40. When I add those two together, I get 55. And you can see that again, I got the same value, 55, either way that I simplified. Now let's look at variables. So using the order of operations, I would normally combine things inside the parentheses first, but I can't combine x and 8. They're not like terms, and I don't know what x's value is going to be, so I can't just say, oh, it'll be 17, because I don't know what the value is for x, so I can't do any simplifying here. So the best I can do is use the distributive property, and this is where it really comes in handy. So I would do 5 times x, so I get 5x, and then 5 times 8, and I'm going to add the result of that, which would be 5 times 8. So 5x, again, without knowing the value for x, I can't do anything further, but 5 times 8, I can. I know that comes to a 40. So I can simplify somewhat by using the distributive property.